Good afternoon, everyone. I would like to welcome you to what is the final webinar which we'll be having this year. Um, Today we will be talking about OpenSearch. We'll provide you with some introduction to the OpenSearch service, and also tell you a little bit more about migrating to OpenSearch. My co-host today is Francisco Gonzalez from AWS, who is our panel expert here regarding the implementation of OpenSearch. Um, so he will be doing the heavy lifting today. The plan for today's meeting is to learn a little bit more about log analytics, observability, security, and search within the OpenSearch services. Then Francesco will also tell us a little bit more about OpenSearch service migrations. To close off, I will be providing a few case studies about how different companies use OpenSearch to gain advantage in their fields. And we will close off by a Q&A where we will be answering any questions that may emerge during the presentation. If you have questions during the presentation, you can ask them via the chat. We will either answer them directly if they will be relevant to the currently discussed topic, or we will just sum it up at the end. The entire webinar will be recorded and made available through YouTube as per usual. So right now, Francesco, I give you the stage. So take us out.
Thank you, Albert. Okay, let me share my screen. Let me know when you see it. You see it, right?
Yes, there it is.
Great. And you also hear me.
That's correct.
Good. So that means we're good. Hello and welcome everyone to this webinar. My name is Francisco Gonzalez. I manage the partner program for Amazon OpenSearch service. Very happy to be here with Hostersi. Working with them is always a pleasure, and they are strong with OpenSearch and OpenSearch service migrations. So we have a very busy agenda, but hopefully it's very interesting for you. First, we're going to provide you with an overview of the Amazon OpenSearch service. Amazon OpenSearch service is the managed service for the open source community project. So we are going to cover both the OpenSearch service and the community project, including benefits, features, and use cases. Then we're going to cover the reasons why customers are looking to migrate to Amazon OpenSearch service. This is key because it will provide you with the information needed about why OpenSearch service is a fantastic offering for your log analytics, search, observability, security workloads. We will then go over the migration process. We have a 6-step process that starts with planning and a proof of concept and ends up with a completed and successful migration to Amazon OpenSearch service. So let's start. So I think the first question is why OpenSearch. So these two are the main two use cases. First, we're going to talk about log analytics and observability, and then about search and full text search. Log analytics and observability is about management of human and machine generated data. Sometimes it's structured, sometimes it's semi-structured. This data may come from different websites, applications, systems, networking, social networks, IoT, and so on. You may need to correlate these logs with other metrics and traces or business insights, and also use advanced features such as machine learning or anomaly detection. Common samples of are performance and security monitoring, observability, alerting, auditing, and also for security purposes. Then we have search and full text search. Our applications require very fast and real-time search at scale with relevant results from structured and semi-structured data. So in this case, we're talking about a document portal, an e-commerce, machine learning, or personalized recommendations. Search is key in OpenSearch the way it works is an inverted index, so it's able to do search on data coming in real time, and that is very useful for many scenarios. Now, let's talk about OpenSearch, the OpenSearch community project. So we have the OpenSearch project and we have the managed service from Amazon. So now we're going to talk about the OpenSearch project. So the OpenSearch project is community driven. It's an open source project for search analytics, and it is a fork of Elasticsearch 7.10. Amazon is committed to the project, and other large organizations are also helping and contributing to this project. OpenSearch has been out now for more than a year and has advanced features, and the team is releasing new features every quarter. Some of the advanced features include high cardinality anomaly detection, trace analytics, dashboards, and more. Some of the key releases were the observability plugin and the security plugin. Now, there are also other reasons why you want to work with an open source project. One is that it's 100% open source, and this means a lot because you as a customer are able to see, review, change, improve, and monetize the code if you want. And this is very relevant. You can build solutions on top of OpenSearch without paying a license. Then is community driven. So any organization is able to contribute and influence the roadmap. And this means that it really captures the market and customer needs because it reacts faster to market trends and customer needs. And then it's enterprise ready. Amazon is pushing for this community project and has an enterprise managed service on top of the OpenSearch project. So it has an enterprise mindset, and that translates to being more secure, more compliance, easier to manage, and easier to scale. Okay, 1 second. Great. So now we're gonna switch to the Amazon OpenSearch service. So it's the managed service for the OpenSearch project, and it includes OpenSearch dashboards, and it supports existing customers with previous versions of Elasticsearch. So we have the community project, and then we have the managed service. Now, Amazon OpenSearch service is the service that customers are buying from Amazon, and it enables you to ingest, secure, search, aggregate, view, and analyze data at multi-petabyte scale without the operational cost of having to manage your own cluster. This is key because you can scale up to 3 petabytes and 200 nodes in a single cluster. And if this is not enough, you can have multiple clusters and then have cross clusters capabilities for search or for active passive and so on. Last week at reInvent, they announced Amazon OpenSearch serverless. So there is also a serverless offering for OpenSearch, and that makes it also very, very attractive for customers. Great. Let's talk now about migration to Amazon OpenSearch service and reasons why we want to migrate to Amazon OpenSearch service. So on top of all the new functionality you have in the new OpenSearch community project, there is a few reasons why you want to migrate to the managed service. So let's start with management and scalability. You can have a very large cluster, as I was mentioning, with 200 nodes and 3 petabytes, and very easy to manage with very advanced functionality such as the cross replication, active passive, upgrades, backups, and more. Uh, Amazon OpenSearch service scales, and this is very important because the existing installation of log analytics and search does not scale, or scaling is very hard. So this is one of the main reasons customers are moving to Amazon OpenSearch service. Data is growing exponentially, and customers need a solution that scales and is able to handle um, all of the workloads that you currently have. Then is price performance. With Graviton processors, you get about 44 better price performance On top of this, you have some features like ultra warm nodes and cold storage, and I'll talk about that in a second, that has a potential of 90% cost reduction. On top of that, you have serverless now, as I was mentioning, that was introduced a reevent last week. And also, you get the great pricing that you get if you run your workloads in AWS, since this is a native services, a native service. Um, Also, in terms of price performance, because OpenSearch is a community project, you will not be paying a license. Now, the third benefit is security and compliance. And here I said, Amazon. This is a very secure service coming from Amazon. So you have encryption with key management service, Cognito, SAML, 24/7 monitoring of your cluster, and many more functionality. You are also in compliance with many standard and industry regulations, such as ISO, FedRAMP, and so on. Now, if we talk about the difference between you managing your OpenSearch installation compared to using the managed service, we have this very interesting table here. So I'm going to start at the right. In the right, we have the scenario for you using the managed service. In this case, Amazon takes care of everything, so you only need to worry about your business, the application for your business, the functionality of the application, and so on. Amazon takes care of the rest. So very easy for you to start building solutions on top of the managed service. If instead you are in the middle, you're using Amazon EC2, that is Amazon Elastic Compute Cloud, and then you are installing and managing OpenSearch. So this is self-managed. You're using the community project and you are running in EC2. In this case, Amazon only takes care of the hardware and operating systems, hardware lifecycle, power, networking, cooling, but you not only need to take care of your business, you also need to figure out things like high availability, backups, 24/7 monitoring, hot nodes, cold storage, cluster scaling, and so on. So there is a lot that you need to do. If instead you're in the left, you're not only taking care of the business and the SO, you're also taking care of everything, including the building security. So that is on premise. Now, if we switch to uh, price performance, we were talking about 90% reduction in 90% better price performance and using Ultra One and nodes and cold storage. So in terms of Graviton, since May 2021, Amazon OpenSearch Service supports Graviton processor instances. Graviton processor instances and processors are designed by AWS to provide better price performance for different types of workloads. What you can see in this chart is that we see a 38% improvement in indexing, 50% less indexing latency, and 40% increase in query performance. So this is great for your OpenSearch service workloads. So it's not only about using Graviton, it's also about a few other functionality that we have in the managed service, such as ultra warm nodes and cold storage. So let me cover this a little bit. Still a very introductory beginner level, but ultra warm nodes provide you with about 90% cost reduction. What ultra warm nodes does is it uses S3 and a sophisticated cache solution. So it only supports reads in S3. So if you need to write, it will automatically return the index to hot storage, and it still has the 3 petabyte limitation. It has less query performance compared to hot nodes, but the great benefit is that it is transparent to your application and business users. They only see a very small decrease in performance. So the most common use case is when you rarely use historical data, let's say data older than 5 years old, or maybe for you is 3 months old. In that case, you move your historical data to ultra warm nodes, you get the 90% cost reduction and a little decrease in performance. Another strategy is to use cold storage. Cold storage provides you with even better price performance, and it uses S3 infrequent access. In this case, data is only available on demand. That means that the indices are moved to S3 infrequent access, and there is no data limit. So we don't have the 3 petabyte limitation. You can move as much data as you need. The only problem is that you have the data on demand, meaning that in order for you to have your data available, you need to move it to an ultra warm node. So customers with large volumes, these are these are customers out there ingesting terabytes or petabytes of data, are using multiple clusters and warm nodes and cold storage strategies. Then it's security. I'll be very quick here, but Amazon OpenSearch Service is actively monitoring your clusters. So if your cluster is not working well, it's a performance issue, but it's also a security issue. So Amazon OpenSearch Service provides automatic replacement of failed nodes. We also don't need to incur in the operational cost of replacing these nodes. So it also helps you increase your price performance from an operational cost point of view. Amazon OpenSearch Service supports data replication for your cluster across 3 availability zones, making it very, very secure. Amazon OpenSearch Service also supports cross-cluster with cross-region replication for active passive. So you can move, you can have an active and a passive replica in a different region, or in a different region in a different location. So maybe it could be in another continent. So we have customers with passive replicas in different continents. So let's now talk about the migration process. Some of your customers or you may have already some workloads for log analytics and search, and you may want to migrate them to Amazon OpenSearch Service. So let's talk about target workloads and different scenarios. So there are many Elasticsearch and some OpenSearch workloads running on-prem or self-managed. By migrating to Amazon OpenSearch Service, they'll be able to scale and improve price performance and take advantage of all the new functionality of the OpenSearch project, including observability and security plugins. There are many other log analytics and search solutions out there, such as Solar, Splunk, or Datadog, facing the same issue: growing data volumes that require scalability, security, price performance, and advanced functionality. The easiest workloads to migrate to Amazon OpenSearch Service are Elasticsearch running on-prem or self-managed, because sometimes it's as easy as restoring a snapshot. There is also many other customers running Splunk or Solar or Datadog, and they may want to migrate some of the workloads to Amazon OpenSearch Service. And these type of migrations require a little bit more of work, but in the end, it provides the functionality that customers require at a scale and with price performance. Okay, so this is the 6-step process that I was talking before. Uh, the first is qualify and plan. Here we spend a very long time, and this is about sizing and planning the migration. Then we have the proof of concept to validate the plan and identify any issues very early in the process and make changes to the plan if needed. Then we jump into deploying the target solution. We copy the data, we upgrade the, the new copy in the target solution in preparation for the swap, and then the last step is the swap. So let's start with qualify and plan. The planning section includes understanding key performance indicators for the migration and your business, a review of the functionality needed, including version dependencies for plugins and integrations with other applications. It also includes operations and security, the deployment framework that we're going to use, and how data is ingested, And we also look at sizing in terms of what resources are needed for the target destination. We also plan for training and adoption for the migration team and also for operations and the business. So in terms of key performance indicators, there is some questions that we need to ask ourselves to start thinking about how relevant the migration is for the business, such as, does business revenue depend on your current solution? That will give you a good idea of how critical the migration is. And then you start building other key performance indicators, such as operational performance. Maybe you want to have latency and input and output KPIs, also process performance, SLAs, uptime, MTTR, tickets, and also search results, insights, anomaly detection, and understand what a successful migration will mean for your business. Then, as part of the qualify and plan, you jump into sizing the solution. Okay. Uh, if we are migrating from an existing Elasticsearch solution, then we have a good understanding of the storage and CPU needed for selecting the instance types. If we are migrating for another type of solution, then the sizing section is a little bit more complex. If we are sizing in terms of storage, an index with one replica is about 2.5 times the size of the source data. And we always leave another 25% overhead. In addition, you need to estimate your weekly or monthly growth. This is why for some workloads, OpenSearch serverless is key, because you may not need to do some of these estimates. Then, in order to provision CPU, a good quick rule is to have 1.v CPUs, virtual CPUs, per shard with substantial traffic. So that's why the proof of concept here is key to understand what you really need. Great. Let's switch into functionality. In functionality, we're still in the qualify and plan phase, and it's key to identify all the systems we are integrating with and what is the functionality required. If we are migrating from Elasticsearch, this may be very simple, since OpenSearch is a fork from Elasticsearch. But even in this case, there are some scenarios that require some effort for you in the migration process. If we are migrating from other log analytics and search solutions, some more work may be needed in order to be done with this step. Maybe we need to modify existing applications, that's the worst case, or building custom code to replicate some of the integrations so it's transparent for the other applications. As with any migration, there may be some functionality that is different in OpenSearch, so it's important to plan these specific scenarios in detail. Then it's also data ingestion, and data ingestion, as you know, is a key part of a log analytics and search solution. The first step in a migration is to review in detail the current ingestion framework. In some cases, we may use exactly the same ingestion framework, but in some other cases, we may want to modernize the framework by using some other powerful platforms such as AWS Kinesis or Kafka, or use some open source plugins such as Logstash or Fluentd. Then it's training and adoption. Um, and this is key. You need to build a comprehensive plan for training and adoption for your training teams. Your existing developers need to understand the new solution, so when they build applications, everything integrates smoothly. Then is your operations, and also your support and security teams. So you need to make sure that there's a training plan in place and that they're ready to manage the managed service, even though there is not much for them to do, but there is still some work they need to do. And then is your business team. Some business users are interacting with the current platform, so they need to uh, go over the new UI, the new user interface, and how the new results are presented, how search works, or log analytics or anomaly detection. So training is key, so your users don't go and say, "Hey, I'm not able to do what I was able to do before the migration." Great. Proof of concept time. This is the most fun. The idea here is that we validate the key functionality. We build the run books and review that all the integrations are going to be working. We review the budget to make sure that everything is aligned with the planning. The sooner we discover issues, the better. And hopefully, the result of the proof of concept is a validated plan to execute the migration. So I always say that for a proof of concept within a migration, the idea is to go over the most difficult scenarios. Um, we're not looking for a quick win here, as we do in some other type of proof of concept. We're trying to uncover anything that may end up failing. Then it's time for deploy. And in this step, what we do is we execute the deployment scripts, review security, monitoring, and alerts. We perform a security penetration test and review that integrations are working. In the end, after the deploy, the system is ready for data copy and sync, and also ready for ingestion, and in order to perform a swap later. In most cases, what takes the most time is making sure that all integrations are working well. Some of those integrations may have required some work before, such as custom developments. So always good to do some testing here to understand if the integrations are working well. Great. It's now time for data copy and to evaluate the data migration patterns that we will be running. So in this step, what we're doing is we're loading data into the deployed solution that we're going to be migrating to. The complexity of this step really depends on the systems we're loading from. Also, the size of the data that we need to move and the channel that we are using for moving the data. Bandwidth, reliability, and security are key aspects when moving data. Sometimes we have a very fast connection that is secure and reliable, but some other time this step may take days because of a slow connection. The last thing we need to look at is how we are extracting, transforming, and loading the data into our destination. So we have three options, okay? So the easiest one is in the middle, is when we are restoring from an Elasticsearch or an OpenSearch snapshot. The one in the left is when we are loading from the real source of data. So maybe there was not a real solution in place, or we were using Oracle, SQL Server, or and or the systems populating the data. And the one in the right is when we have an existing log analytics and search engine, such as Splunk or Solar, and we may migrate from the existing data in Splunk or Solar. So let's start building, um, let's start with loading the data from the source of data. So the one in the left. Okay, so there we go. This is the slide. When we're loading data from the source of the data, uh, we're loading from business systems or repositories. The OpenSearch API is expecting a JSON. So if we're not able to collect data in JSON format, we will need to transform it to a JSON. In most cases, data is in a database or a storage system. If it lives in a database, we may be connecting to SQL, Oracle, MySQL, DB2, Aurora, and or maybe we're connecting directly to the source system, such as SAP or Salesforce. We could also connect to a NoSQL database and or the file system. And sometimes the data may be in different formats, such as a PDF, CSV, Parquet, ORC, and so on. So if we are building from the source, we have different techniques. So in some cases, we may end up building our own custom code to connect, transform, and load the data. And you can run this code in EC2 or serverless Lambda. You can also use connector-based tools such as FluentD, Data Prepper, or Logstacks. These software connectors are ready for you to use, and it makes collection, transformation, and loading much easier. And maybe you're running this in EC2. Um, you may also use extraction, transformation, and loading tools such as AWS Glue. AWS Glue is a great tool for extracting, transforming, and loading your data, and it supports views, making it even easier for you to load data to OpenSearch service. Now, if we have a snapshot, then it may be a very simple step. We go and restore the snapshot. Newer versions of OpenSearch in most cases read the last major version. And then once you restore the snapshot, we strongly recommend that you do the reindexing of the data once the snapshots are restored. Are restored. So you need to plan for the CPU needed to restore before going live. Then it's building from an S16 engine. In most cases, S16 engines make it easy for you to start data, hopefully, but in some cases, it's not that easy. There are different ways for you to extract the data from an existing engine. You can create your custom code and run it in EC2 or serverless Lambda. You can use Glue to do the integration, and in some cases, you can use a plugin such as Logstacks. And when you are connecting to an existing engine, there is some planning that needs to be done because you need permission, networking, authorization. So that's how it normally works. So I said this is a very high level beginner into the migration process, but I hope after reviewing these three data loaded options, you are now more ready to move to the next step. And the next step is once we have the data and the replica that we created, we need to make sure that we are able to update the data to the current state. So how do we do this? If it's a log analytics, we may be able to run both systems in parallel, having both systems ingesting data and then backfill the prior data. If it's search, ingestion may need to be stopped and then run some type of CDC, change the capture, mechanism to backfill the changes to then start the ingestion again in the new system. So it really depends here, the update and sync on your source system, if they allow you to have CDC or to run ingestion in parallel. So once you're ready, it's time for the swap, and this is the last step. Um, so once we're here, all the ingestion needs to be flowing to the current environment, and the integrations with other systems such as front-end applications need to be happening. In order for the integrations to happen, you may need to require to change the front-end application or the DNS in order to redirect to the new OpenSearch installation. In most cases, you don't need to, but sometimes you need to consider a rollback plan. This is something you will need to decide at the very beginning in the planning phase, and it depends on the business impact and the complexity of the migration and the potential uh, downtime. So hopefully you have now a high level understanding of the migration process. So let's wrap up. The main reasons why customers are migrating to Amazon OpenSearch Service is functionality, price performance, management and scalability, and security. The current installation on-prem and self-managed is running out of space or capacity. It's consuming budget, doesn't have the functionality, or doesn't even have any functionality because it's already overloaded with data. So it's in a cold storage without functionality. So Amazon OpenSearch Service gives you the management and scalability, the price performance, and the security. Now with the new OpenSearch serverless option is even more interesting because you don't need to allocate all those nodes for your clusters to plan future growth. Then, if you are running a migration, Hostersi is ready to help you, and we have a 6-step process to support the migration process. And in most cases, these migrations will be very simple, and you get great return on investment. So thank you very much for attending this section. So let's now hear the customer stories. Albert, I'll hand it to you.
Yeah, thank you very much. So, right, we've got two small case studies for you today showing how OpenSearch may be utilized. I will basically follow up on what Francisco said regarding the benefits. So in all the cases, the ease of usage and the benefits of using it were very decisive when deciding on using OpenSearch. So first off, we start with Modento, which is a case study that we have helped the customer to implement. So Modento is a software solution for dental centers that allows managing patient data, eliminates paper forms, provides comprehensive tools to schedule meetings, remind them through SMS, email channels, and so on. The solution we started with was running on traditional VPS-centric infrastructure with no high availability, no auto-scaling, and also one key requirement for the entire transformation was that as a medical solution, it would have to meet the standards of HIPAA, which are necessary in this field. So on the technical side, what we end up doing is setting up a target cluster with Docker images, where Docker images were downloaded and deployed, and this allowed to divide the application into several smaller containers embedded in separate websites, and each of the services started running autonomously with its own auto scaling and high availability. So where does OpenSearch factor in? Because this was a solution that had to facilitate HIPAA requirements, one of the bigger challenges there was the fact that log data needs to be stored for 6 years and also needs to be easily accessible whenever necessary. So with this amount of data, which is generated by the application, it was very inefficient or even impossible to manage it by a solution that is run manually. So this is where we decided on OpenSearch because it allowed us the flexibility and the ease of implementation to offer search features that would help us to get to grips with the logging. And also, one added benefit of OpenSearch is that it easily integrates into Kibana, which was already used by us and by the customer. So it was very easy to just stay with the same tool, but have the added visibility and monitoring provided by OpenSearch. Another example, which this time comes directly from AWS, is Pinterest. I think it's a service that everybody here knows, even if you are not using it actively. I will briefly touch upon how they are using OpenSearch in their operations. So the website Pinterest has about 400 million users right now, which this amount of people on the website generates hundreds of gigabytes of log data per day. So initially, the company was using a self-managed open source Elasticsearch tool to analyze the log data. However, with the still increasing number of users, the solution started to be a little bit stale and really could not handle the scale of data which the site was generating. Furthermore, it also required constant administrative work from the company's engineering staff. So in effect, the data analysis was very unsustainable with quite a large overhead in the operational department. So because of these problems, the company started looking for an alternative solution, which they found in Amazon OpenSearch services. The greatest benefit they reported from implementing this solution lies in the scalability and ease of management. So because it's a managed service in AWS, it helped to free up time from the engineers who would do low value work maintaining the old solution to really providing benefits into the application, so developing new features, working with the users. And thanks to OpenSearch, the entire pipeline for the log management and analysis right now is managed by one person as opposed to an entire team which was needed before. Also, by integrating monitoring and alerting capabilities with the software development process that are offered by OpenSearch, the company reports on 30% cost reduction in terms of software development and log analysis. And also, the amount of data analyzed by the observability team has increased from 500 gigabyte of data per day to 1.7 terabyte per data that can be analyzed within a single day. So it's a very, very big increase given how big the entire infrastructure and the log data of Pinterest is. So these are two examples of what OpenSearch is best for. So whenever you need to manage quite a lot of log data, this is a solution which you should definitely consider. And with that, I would like to go over to the Q&A. So if you have any questions, please use the chat window. Maybe I'll start with a rather simple question, because I don't think that, Francesco, you've mentioned it. But if you want to start with OpenSearch, is there some free tier service that you can use, or some demo version available? Could you maybe give some more information on that?
Yes, there is a free tier um, that you can use for Amazon OpenSearch service, the managed service, and if you are testing something very simple, you can still download the OpenSearch community project. It's the same as the managed service, and running on-prem on your laptop or running on EC2, and there is also some free tiers there. So that would be a good starting point.
Okay, thank you. Okay, so I don't see any more questions appearing right now. So I'm assuming that we've made everything very clear to the people here. If anyone wants to contact us regarding OpenSearch or any other AWS related questions, here are our contact details, so you can reach me easily through Hostersi and through LinkedIn, and also Francisco is also available under his email address. So if you have any questions, feel free to contact us. We will be happy to help and answer any questions you might have. And with that, thank you very much for your attention. Thank you very much, Francisco, for being with us, taking the time. I know it's like very early in the morning where you are right now.
It's good.
So I'm happy that you are here. And to everyone, thank you for the entire year of webinars which we were able to provide to you. And let's see you next year. Bye-bye.
Great. Thank you very much. Bye bye.